Now, first of all, welcome to all of you for participating in this webinar. This webinar will be about rebar modeling in COMOSYS. Now, as you know, rebar modeling is a bit of a challenge generally in 3D modeling programs. So I want to show you a few things which are unique to COMOSYS in some ways. And I will be in particular, because the topic is very vast and there are many things to show, but I obviously cannot discuss everything. So we will be talking about just one feature of COMOSYS, which is called the surface macro technology. Now, the surface macro technology is interesting because unlike other macros, normal macros, which if you make it once after using a macro, if you make any manual changes and the macro is run again, then your manual changes are lost because the macro basically runs again and you lose whatever changes you had made manually. But with the surface macro technology, we have something interesting which we call operations, and I'll explain them when we get to them. But using these operations, what we can achieve is that even the manual changes which we make after the surface macro has been applied can be maintained or can be reapplied automatically, even if the surface macro needs to run again. So we'll understand that a bit more when we get to it. So let me quickly start then. I'll start with something very simple. Now, in concrete, is basically about surfaces. Everything is basically a surface. If you think about a slab, if you think about a wall, if you think about a large foundation, it's usually surfaces. And you're creating your rebars on these surfaces. Surfaces can get very complex. If you think about it, even beams and columns are actually just surfaces, and you've got your rebars on those surfaces most of the time. So let's start with a very simple surface. So this is a rectangular, the most simplest surface. The top of the slab is the simplest surface you can find. So if I go and go to my surface macro, and I select the slab, and I right click, and then it asks me for a surface. So I can show it a surface. And once I show it the surface, then it asks me for a direction for the main rebar. So every surface has a main direction and a secondary direction. So it's asking me for the main direction. So if I go something like this, immediately it creates my basic rebars, both in the main as well as in the secondary direction. This is in my control. I can only create the main. I can only create the secondary if I want. So it's very simple. You just go and you click on it. You select the surface, and it will create your surface rebars. So basically two rebars in this case. Now, one nice feature to have over here is that the direction which I chose for the main direction doesn't necessarily have to be in the direction of the slab itself. So, for example, I could go over here, do like that, select my surface, and then after selecting my surface, I could show maybe a direction like this. If I show that, then my rebars are created in that direction, because the different part positions require these to be in separate parts. So by changing my direction for my main direction, I can create on the same surface along a different direction, both the main and the secondary. Now, let's move on to more complicated cases. This was, of course, the most simple, but here we just had two bars. But imagine this one. You can imagine something much more complicated than this one as well. Now, over here, we have the top surface, and we have several holes over here as well. And because of this, now it's not going to be just two rebars. There's going to be a rebar over here, one over here, one over here, one over here, 5, 6, 7, 8, basically maybe 20, 10, 20, 25, I don't know how many rebars will be created. So if I go to my surface macro again and I show this one and I select the top surface and then I show a direction for the main, let's say I select this one to be the main direction, automatically all my rebars are created. And if I go to the top view, you will see that there's one rebar which is created over here. There's one over here. There's one over here. There's one over here. And what's nice about this is that if you notice, the clear covers have been maintained at all points. So normally with many softwares, the program will start off with the correct clear cover at this point. But then whatever your spacing is, maybe you get over here, and then with this hole, you don't get a bar exactly at the clear cover point. So what they will do is you might have a bar over here, and the next bar will be over here somewhere. And so this hole doesn't really get the aligned bar, which is problematic because then what you need to do is there are so many bars over here. You need to go to every hole and you have to basically modify the range of these rebars on the left and on the right and on the top and on the bottom. But with COMOSYS, every single one of those holes and the boundaries of that concrete object is respected. And the program will automatically, the surface rebar technology will automatically find those edges which need to be respected from a clear cover point of view and adjust them, because this will save you a lot of time. So one thing, let me just say that you can enter your questions in the chat or question and answer section, and we'll try to get back to them towards the end. So this is very important, I think, that the ability to respect your clear covers wherever your edges, the edges which need to be respected are. Now, once you've placed your surface macro, you can actually make changes. So if I were to go inside and make changes to my hole size, for example, if I make this 2,200, the width, and if I change it, the entire slab will adjust according to this change in the geometry. I could go on, for example, over here. I could make changes to this one, make this one 1,500, for example. And if I made this change, all the rebars will immediately respect this new setting. Or what I could do is I could make new holes. So for example, I could go in and select the rebar, the slab, and make a new hole over here. And once again, the entire slab will adjust according to this new geometric situation which we have. So we can change the sizes of the holes. We can add new holes. We can move them around. We can physically move. For example, I could select this one and maybe right click on it and say move linear. And I could say move linear in the minus X direction. And if I move that cut, then the rebars will modify themselves. And once again, all those boundary edges, this is very important because every time you make changes, all that needs to be recalculated. And this is very important that we get something which is directly usable. Now, the good thing about this whole surface macro technology is that I created all these rebars with a single macro, but that doesn't mean that now my diameter and spacing and those options will need to apply for the entire slab. I actually have individual control over all the individual sections. So for example, this particular section, this bar going like that, if I wanted to, I could make individual changes to just this one. So for example, I could go in there and instead of a spacing of 250, if I ask for a spacing of 500, then only that particular area can have its own spacing, and it's once again it's respecting the clear covers on all sides. If I wanted, I could make the change to its diameter as well of only that particular rebar which we have over here. Now let's do some more changes. For example, let me show you some things about embedment options. Now, embedment options are interesting because, for example, this bar over here is just come and stopped at the end. Now, if I were to open up this sub portion of the total surface macro, so the surface macro, this is a sub portion only, not the entire slab. And there's a start point and there's an end point on the other side. Now, at the start point, you see it says do nothing. But if I can say go to the closest segment. Go to the closest surface. Now, if I do that, this particular rebar will automatically follow my the geometry of the slab and go to the closest segment. And this is embedded now. This particular bar, all the other bars are not, because that's what the setting was. I can change that setting as well, initially and later. But what I'm showing you over here is that I have control over all these individual rebars, and I can go back and change the diameter and spacing of all of them and keep this one like this and the others in the other way. I could do something else as well. I've got some other embedment options. Got things like, so I showed you to closest segment, which basically means you turn and you go to the closest point and you stop over there. But I could also say by embedment length. And if I say by embedment length, it asks me for a multiplier of the diameter. So if I say 50 phi, whatever the diameter is, and I say, okay, then it calculates the 50 phi of the diameter, which is 20 millimeters, I think, in this case. And it realizes that it needs to turn inside the slab to satisfy the 50 phi. So it's actually me calculating how much it needs to go. All I need to tell it is go 50 phi. If I tell it to go 30 phi, for example, it will not need to turn. It'll just stop over there. If I tell it to go 75 phi, the diameter basically, then it'll go even more inside. And it'll basically respect the shape of the concrete around it. It'll intelligently sense where the concrete is going. And whatever the shape of the concrete is, I'll give you a more detailed example of this later as well. Now, this is basically the initial benefit which we get, that immediately with using the surface macro, it finds all these regions for us and finds all these and respects the boundaries, like I said, respects the clear cover areas, like I said, and places all that rebar for me in a single go on the entire surface. But after I've done that, let me bring this back to normal so I can show you some more things. I can bring back to do nothing. After I've done that, I can make more changes on this. And these changes are done by what we call operations. And operations are of two types. You've got operations on the path and operations on the range. And this operations on path basically tells me that I can change the shape of the rebar itself by changing its path. And the range basically does exactly that. It changes the range over which the rebar is placed. So I can make and there are many different types, and you might be wondering what all those types are for, but I'll just go through some of the more important ones. So let's start by maybe this example over here. So we have a slab, and let me use the surface macro once again, like that. I select the top surface, and then I basically go and select my bar direction. Now, so we see some beams over here as well, right? And these beams are actually clashing with the slab, but that's fine because COMOSYS will merge them all together. But I just want to show you something over here. If I look at it from the plan view, you see that this directional rebar of the slab actually should not be in the areas where the beams are, because the beams will have their own reinforcement. So I will, for example, go in there and maybe put some reinforcement for the beams over here, right? And now the beam's own longitudinal reinforcement is actually clashing with the reinforcement of the slab. So we have a very nice operation. If you remember, we were calling it operations, in which, so I'm talking about these longitudinal rebars of the slab. They're basically getting into the area of the beams. So we have an operation on range, which is called conform rebar macros to the formwork objects. So it'll take an existing rebar surface macro and it'll conform it to some other objects, in this case, the beams, for example. So if I do that, it'll ask me for which rebar macro I want to conform, which is this direction main rebar. So I select that, I right click. I could do a multiple selection as well, by the way. Now it's asking me for the objects which it needs to respect. So I just select this beam, I right click to confirm. I select this beam, right click to confirm. This one, right click to confirm. This one, right click to confirm. And this one, and right click to confirm, and then no more beams. And when I do that, immediately you see it empties out those areas where the beams are. And because now this is exactly what I want, because now I can, if I look at it from the plan view, my beam reinforcement is now clear. And this one is the slab reinforcement, and it is exactly at the clear cover outside the beam, which I can adjust. So very conveniently, I have this option of emptying out basically the several regions of this surface macro, and I can still control it. It's still in my control. I can go back and change the spacing of this of the surface macro. I can, for example, change it from 250 to maybe 150, and it'll recalculate the whole thing itself, but it will also still remove those areas. So I've actually gone back to the original surface macro, and I made a change to the spacing options over there for all of them. And yet it has also remembered that after the surface macro, I had created this opening over here for the beams. So it's still respecting that. So it doesn't bring me back to square one. That's the important part. Let me see what I have next. So for example, this one, these bars in the secondary direction, maybe they're being blocked. If I look at it in the plan view, there's a wall over there, and these secondary bars should not be in the area where the wall is. As you can see over there, maybe it's difficult to see, but I'll try to show it in a second. Yeah, so all I need to do is then go into my range operations, the same operation which I just did. And I can say this direction, the secondary direction rebars, right click, and then they're asking me for the objects to be conformed. I can just select this wall now and right click, and then no other object. And immediately, if you see, it has emptied out that area, cleared out that area which was going into the region where the wall was. And now I can use some other macro to place my wall reinforcement, and the slab reinforcement will not interfere with it. Now, this is quite nice. One more thing, another thing which I can do, for example, so this is, if you remember, I used the surface macro to put all these rebars in a single go. But let's say I wanted to have a little column over here, for example. And these ones, if I wanted to kind of break them without destroying the surface macro, because I might be needing to change the spacing or diameter later on. So what I want is to just insert some of the bars which are aligned with the column inside the column. I want to embed them inside the column, which is a separate object, by the way. It's not the slab. What do I do for that? If I look at it from the plan view, go like that, I can see that this is the rebar I'm talking about. So what I can do is I have something called conform rebar to a point. So I can just select this one. And the point I want is just about the clear cover above this point of the column. Or sorry, inside, just inside the column. So if I just go like that and I say dy, let's say the clear cover is 50, including the bar diameter. If I do that and I right click, immediately this bar over here is divided into two parts, this one over here and that one over there. And then I do it again. I do the same operation again, conform a rebar to a point. And this time I do dy plus 50 because it's on the other side of the column now. And I do that. And I've got my rebar broken. Now, basically, if you look at it, this was a single rebar. I've broken it into three separate parts, but they're still intelligent. They're still, they have their spacing. They're all together. So what I can do now is I can show you another operation, which is called the embed into object operation. So what I'll tell it is to embed this particular part of that surface rebar into the column. So let's go to this path operation called embed your rebar into the formwork object. So I select my rebar, then it asks for a point. So I know it's the end point, so it's this one. And then it asks me for the objects which need to be unioned. So it knows the slab already, but it doesn't know about the column. So I'm going to say, take the slab, right click, take the column, right click, and nothing else. And when I do that, that particular portion, if I just go back to my plan view, you can see that only those rebars over there have been pushed inside the column. And once again, if you can see over there, the embedment length is, let me show you something called, I can list the operations which I've just done. So if I select this one, it tells me that I have used this operation, the embed rebars into objects. And if I were to go in there and I say, instead of 50 phi, if I were to say 90 phi, for example, it's going to respect, let me make it 100 phi maybe, or 120 phi even. And if I do that, it goes back inside the column, turns inside and turns back inside the slab, because they're now unioned together as one object. It knows that geometry. So it's very intelligently now joining the two and find whatever your embedment length is. But let me go back in there and do this. Let me double click on that. Let me bring this back to 50 phi. So it's coming back like that. But what I can also do at this point is I can actually reverse. Maybe if I don't like the direction in which it went into the wall, I can just say reverse the embedment direction. And if I do that, the embedment direction in that unioned object is reversed. And if you notice, if I were to, for example, take this surface macro, but this surface macro is actually both this one and this one and this one. If you remember, they were all three were together. So if I just take any one of them even and say like that, and I change the spacing to 150 instead of 250, I will not lose what I did. If you notice, the surface macro runs again with the new spacing for this area, but the operation which I did, which inserted those local rebars inside the column, are still maintained. So I can still have those rebars going inside the column even after I'm changing the spacing of the rebars. Okay, let me move on. Let's see what I have next. Okay, I've shown the embedment into another object. Now, another thing which I can show you over here is if I change the diameter of this rebar, the 50 phi. So for example, if I were to just go into this surface rebar, and instead of a 20 phi diameter, if I chose a bigger diameter, the embedment length, because it's 50 phi, is also going to change. It's automatically going to calculate a new embedment length depending on the new diameter which I have. So this is extremely useful. and basically just making it changes, which I originally, what I'd started off with was just created this, use the surface macro for finding all the regions which respected the boundaries of the edges for the clear cover. And then after doing that, what I did was I just started using my operations. And the operations are not only respecting the boundaries, but they can also be triggered right from the start by using the same surface macro, and the operations still maintain themselves and they recalculate themselves. Okay, let's continue. We change the diameter. We see now we reverse the direction. We can change the spacing of the main surface macro and see what happens. Let me go about another operation which is interesting, which is breaking a surface macro at a point. So, for example, this is a surface macro inside. This is a part of that region. I can actually break this. So the bar is going like that, and what I can do is, if I go to the path operations, I can say divide or delete from a point. So what I can do is I can go there, I can select this, and then I can select this bar, for example, right click, no more bars to be selected, then asks for a point. So I can select this maybe the edge of the hole, and say x maybe minus 50 from there. Let's say I want it to be like that, and it asks me for the side which needs to be kept. So if I do that, I'm actually reducing, I'm basically emptying out this region for maybe something else which I want to do. So I've broken this surface rebar. Now I can, even if I go and run the macro again, the surface macro, and I reduce the spacing to something else or change it, this operation still exists. Although the surface macro is for this entire region, this entire sub-region of the slab, but it knows that after changing the diameter, it still needs to break this rebar at this point. Okay, that's something which is also quite useful when you're having your starter bars and you're embedding something into something, and you want to keep a piece of the whole placement and not the whole. You can use this break feature as well. Now, let's see, delete a rebar. We talked about that. One thing which I can talk about is, for example, if I come over here, let me just select this and change the draw mode to wireframe. So this is another part. Once again, don't forget that this entire slab is basically one big surface macro, and I'm making changes to locally. So let me go in there, and I've got a utility which says put end plates to the rebars. So if I were to just select this one and select this point, I can create these couplers very easily. And then I can, even if I were to go back to my list operations, I can actually change them. I can double click on that, and I can maybe change them to rectangular if I want, or give them an offset, basically. And I still have my original rebar, because if I go to my surface rebar over there and change my spacing from 250 to 500, the new things, that whole thing is calculated again from scratch. So this is also quite useful, if you notice. Now, another thing which I can do is, for example, sometimes we have situations where we need a lot of rebar, and the maximum diameter which we've used, which is available, is not big enough. So we need to put two bars together. So this is another nice feature which we have, which we can double the rebars. For example, if I just select this particular surface macro, I can just double the rebars over there, and once again, the original surface macro is still there. If I just go in there and I change my spacing from 250 to 500, for example, you can see it's still respected. Let me go change the draw mode again. Yeah. So all these operations basically move together with the original rebar. Let me talk about splicing now, because I don't want to take too much extra time. Splicing is very important. This rebar over here is very long. It's longer than whatever, 12 millimeters. I've got my splicing options. So let me just go to my splice option over there and apply my classical splice. to this longitudinal rebar and right-click again. So it immediately puts a splice on that depending on my settings. My settings are at the moment at 6 meters. You can change that to 12. It's 6 meters, then another 6 meters, the second splice. And if you see this length has been calculated automatically, and if I go in and list my operations on that rebar, it's 50 feet. So if I were to go to my original surface macro and change the diameter from 20 to something else, 30, for example, you will see that the splice length will also be recalculated automatically at both points. Let me go back in there and list my operations over there and show you something which I can do. Let me delete the splice on that. So it comes back to its original shape. And let me go in there and talk about a staggered splice. Now, if I do the staggered splice option, I can just once again select this one, right click, and you can see it has the ability of splicing in a staggered way. I have total control over these inputs. It comes back to that staggered point very easily. And this is just like an operation now. I can even go back in there, back to the original surface macro and change my spacing parameters. And the splice is remembered. The splices are applied as we change those spacing parameters. Very useful, very convenient. We can do multiple faces, for example. So one thing I want to show you very quickly, just give me 2 more minutes. And if you remember, I had put the rebars on the entire surface. I can actually put them on subsurfaces as well. So what that means is, like, if I go in there, if I go in there and select this one, right click. Now, if I select this surface, it's going and ask for a direction. So I'm going to give it that direction. Now it's asking me for sub-regions. So I don't need to put it on the entire slab. I can say, okay, put it over here, put it over here, and put it over here, and right click. And then in the other direction, put it over here, and put it over here, and right click. And when I do that, immediately only those areas which I wanted have been reinforced. So this is also very, very practical, very, very useful. One last option over here is not on individual surfaces, but on multiple surfaces. So what that would mean is multiple entire surfaces. So what that means is if I have this object over here, I can select this surface, this top surface, this top surface, this one, and this one, and right click. I'm sorry, I forgot to give the direction. Let me just go back in there. So yeah, this one, and 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 right click, and then the main direction. And if you see, all those surfaces have been, the rebars have been placed in a single go. One final thing, just give me 1 more minute, which is interesting, is multiple objects. So when we have multiple objects and we want to kind of combine them together before we use the surface macro. So if we do that, what I can do is I can select them beforehand, before I enter the surface macro, and come over here. And this time it joins them together and shows me what surfaces are possible. And if I do that, and I basically give it the reinforcement direction, it will produce all that rebar according to the unioned object, if you will. So if you notice over here, this one is going from there to there, then this one is going longer, then there's another one over here. So the entire thing has been brought together, and the surface macro has realized that how I can union them, and has brought everything together. This is all very useful. This you can also use it on a circular one, by the way. So if I were to just go on a circular plate, right click, and show the entire surface, and then I show my X direction for the rebar, I can use that same surface macro for circular rebars as well. I can use it for alignment. There's some things that I didn't get time to show you, but as I'm sure you must have noticed, that this whole idea of the surface macro along with operations is extremely useful. And it really makes the job of the 3D rebar detailer very easy. Now I'm going to stop talking at this point. I'm going to stop sharing and go back and see if there are any questions.